This video is going to cover Chapter 11, Section 7, and it's going to cover volume of pyramids and cones. So if you think about it, what we're going to be doing is we're basically going to be finding the volume of a prism, and then if you were to take your pyramid and put it inside that prism, it would be like we were shaving off 1/3 of the prism. So this is how we can come up with our formula. So we would have volume is 1/3 area of the base times the height. Because if you recall, volume of a prism is area of the base times the height. Same thing when we talk about the cones. So if I were to draw a cone here and then place it in a cylinder, again, it's like we're taking off 1/3 of that cylinder. So again, the formula for volume of a cylinder was capital B times H, or pi r squared times height. And then this was for the cylinder. And now for the cone, we're going to take that same formula, but we're going to multiply it by 1/3. Pi r squared, or 1/3 area of the base times the height. And again, this is like a prism, but instead our base is a circle. So let's go ahead and take a look. And when we're doing these, they're all going to be regular pyramids. So if I were to refer to a regular quadrilateral, that would be a square pyramid. So if I said we have a regular quadrilateral pyramid, what I would be talking about is a square pyramid. And if I were talking about a regular triangular pyramid, then I know that my base would be an equilateral triangle. So if it's a regular triangular pyramid, the base will be an equilateral triangle. So all of the lateral edges are going to be congruent. All the lateral faces are going to be congruent, isosceles triangle. And the altitude of our pyramid is going to meet the base at its center. So for example, if I were to draw a square pyramid here, I'll start by drawing a triangle. I'll draw one over here. And I'll draw in the sides that you don't see. So the height of this pyramid would be here at the center of the base, and it would go up, and it would be indicated by a right angle. You would see congruency marks on all of these sides because, again, it needs to be a regular polygon. That's the base. It needs to be a square when it's a quadrilateral. So our Theorem 11.9 is the formula for volume of a pyramid. And I actually showed you this on the first slide, where the capital B represents the area of the base, and the H will be the height of the pyramid. So 1/3 times the area of the base times the height. Next is the formula for volume of a cone, Theorem 11.10. And again, we don't need to worry about the number of the theorem. All we need to do is memorize this formula. But again, remember, since we are doing this virtually at home, when we take this test, you can have your formulas written down on a piece of paper. So again, remember, the capital B represents the area of the base, and the base shape on my cone is a circle, and the formula for area of a circle is pi r squared. So let's go ahead and do some examples. So it tells me I have a regular square pyramid. So let me go ahead and sketch a pyramid here. Again, I like to draw a triangle, then draw another triangle on the side, and then draw in these things here. Okay, so we have our square pyramid. It tells me that it has a base edge of 6. So this tells me all of these sides on the base are 6. It's a square. And then it also told me that I have a lateral edge, which is 5 centimeters. The lateral edge is this right here. It's all of these that go down here. These are all 5s. So the formula that I need to do here when I'm trying to find the volume of this pyramid, remember, is volume is equal to 1/3 area of the base times how tall it is. So we can see that my base shape, my capital B, is a square. So this is easy. It's just going to be 6 times 6. So it's 36 centimeters squared. Now, what I don't have is the height of this pyramid. So I need to calculate it. And there's 2 ways that I can go about finding the height of the pyramid. So let me go ahead and draw in my height. So again, it's going to hit the center of the square, and then it's going to go up to the top, and it's going to be the right angle. Now, I can either, there's 2 ways I can do this. The first way, and I'm not going to use this method, is I could go ahead and make a radius and form a triangle with the lateral edge, the radius, and the height. Now notice all I have so far is that lateral edge. So instead, what I'm going to do is, in order to find the height, I'm going to make my triangle, and I am going to use the base edge and the slant height and the height. So, or half of the base edge. So I'm going to go ahead and form my triangle over here. And then I'm going to go ahead and I'm going to use the slant height. And this is going to form a right triangle. Now notice this segment right here. This is actually my apothem. Now what I'm going to go ahead and do is I'm going to use my lateral face to find the slant height. So what I'm going to do is I'm going to pull out this triangle here, my lateral face. Notice it's isosceles because I have the lateral edge, and I also know that this base edge is 6. As soon as I draw in the altitude, it's going to bisect that side length, and this is 6. So now you can see that this slant height, or this L, which is what you use when you're doing surface area, this is actually a triple. This is your 3, 4, 5. So my slant height here is 4. So this side right here, this leg, or this hypotenuse here, is 4. Now what I need to do is I still need to find the height. So this leg here was 3. So now I can do Pythagorean theorem. So height squared plus 3 squared equals 4 squared. Height squared plus 9 equals 16. Subtract the 9. H squared equals 7. Square root both sides. And the height of my pyramid is the square root of 7. Now that I have the height, I can go back to my volume formula. 1/3 capital BH. 1/3 area of my base was 36. My height is the square root of 7. I'm going to simplify diagonally here. Change this to a 12. And my volume is 12 square root 7 centimeters cubed. So this, when we're trying to find the different pieces, we're gonna have to bring in Pythagorean theorem or special right triangles in order to find missing pieces if we're not given everything we need to begin. Let's try another example. Now for this one, the way that it's written, it is a bit challenging. We're gonna get a lot of fractions. So to simplify this, I'm going to go ahead and change and take off the word slant, and I'm just going to say that the 9 centimeters is the height of my pyramid. So let me go ahead and draw a pyramid here. I'm going to start with drawing the base. And again, remember, it's regular. It tells me it's a base perimeter of 12. So if I do 12 divided by 3, I know each one of these sides is 4. So let me go ahead and add in these lateral edges. And then I also have the height here, which is hitting right here, because I'm going to need that, and that height is 9 centimeters. So now what I need to do, remember my formula for volume is 1/3 capital B times height. So the area of the base times the height. I need to find the area of the base. So remember, to find area of this base, and our base is a triangle, we can either do 1/2 BH, or I could use that polygon formula, 1/2 ANS. And I'm actually going to use this one because this isn't a right triangle on the bottom, it's an equilateral. So let me go ahead and pull my base out. I'm actually going to flip this blue base around and draw it like this. And this is 4, 4, and 4. And now remember, what we have here is we've got an equilateral triangle, and what we can do here is we can actually do this 2 ways, but let me do it this way. I'm going to find the apothem. So I'm going to find this segment here. So again, remember, this central angle here is 120. So when I pull it out, 60, 30, and then the right angle. So right here, this has been bisected. This is 2. And this 2 is supposed to have been equal to, it's opposite the 60. So this is x root 3. This is x. And this is 2x. So here, if I divide by root 3, then I get x equals 2 over root 3. I have to rationalize 2 root 3 over 3. This is going to be my apothem. So this is my apothem. So 1/2, 2 root 3 over 3. Number of sides is 3. And then the side length is going to be 4. So I can simplify, simplify. And my final answer for my base area is 4 square root 3. So now I can plug it into the volume formula. 1/3 capital BH, 1/3 4 square root 3 times the height, which is 9. Can take 1/3 of 9, make it a 3. So my volume is 12 square root 3 centimeters cubed. the base was centimeters squared. Now, I could have also turned that equilateral triangle. I could have found the height of it. There is other ways to do it. I could have also taken the base, 4, 4, 4. Remember that each one of these are 60. So another way to find the base area, drop down your altitude, because I need to find the height. So then now what would have happened is I had a right triangle here, 60, 30, and then the hypotenuse was 4, so this would have been 2, and then this would have been 2 root 3. So then I could have also done 1/2 BH, 1/2, my base is 4, my height would have been 2 square root 3. I could take that away, and I can also get the area of the base that way, and then plug it in. So you could have either used this formula 1/2 BH or the 1/2 ANS. Either way. Let's try another one. This time we also have a regular triangular pyramid. So again, let me draw another one. So here is my base. And then let me draw in these lateral edges. And let's draw in the height. So this time it says the height of the regular triangular pyramid is 6 centimeters. It says the radius of the base is 8 centimeters. So I have a radius that's going from here, where the height meets, to here, and that's 8. So again, what I need to do is use my special right triangles. I'm going to go ahead and pull the blue base out, and again, I'm going to flip it over. I'm going to draw in my radius. I'm going to draw 2 of them, 8 and 8. Remember the central angle here is 120. And then what I'm going to do is pull out the triangle, because I'm going to make a special right triangle. Drop in my altitude here. So it bisects it at 60 and 30. And now what we were given was this side is 8. So this is actually equal to 2x. So x, which is across from the 30, is 4. And this is x root 3. So 4 square root 3. So remember, this is just one side of it. So this side over here is also 4 square root 3. So the side length is going to be 8 square root 3. Because I'm going to add these two. So that makes up the entire side, which is up here. So now let's go ahead and use, for the area of the base, the 1/2 ANS. So area of my base is 1/2. My apothem is 4. Number of sides in a triangle is 3. And the side length is 8 square root 3. I now can multiply. I'll take 1/2 of 4. And now multiply 2 times 3 times 8. And I get 48 square root 3. And these are centimeters squared. And now to do the volume, 1/3 capital BH, 1/3 48 square root 3 times the height, which is 6. I could find 1/3 of 6, which is 2. And then 48 times 2 is 96 square root 3 centimeters cubed. Let's do a cone now. So it first wants me to find the base, the area of the base, and the volume. So again, remember the formula we're using for base. Our base shape is a circle. So pi r squared, and our volume of a cone is 1/3 pi r squared times height. So this is a diameter, so I'm going to split it, and my radius is 12. Notice this is a slant height, so I'm going to form a right triangle in order to find the height. This is actually a triple. It's the 5, 12, 13. However, if you weren't sure, you would do h squared plus 12 squared equals 13 squared. H squared plus 144 equals 169. Subtract 144. H squared equals 25, square root, and the height of my cone is 5. So for the base area, remember it was pi r squared. I didn't need it. All I needed was the radius. So pi times 12 squared is 144 pi, and these are meters squared. Volume, 1/3 pi r squared height, 1/3. Now I've already done the pi r squared, so I can just put in 144 pi times the height, which is 5. None of these are, well, actually 144 is divisible by 3. Goes in here 48 times, and then 48 times 5 is 240 pi meters cubed. That is the volume of that cone. Next, we have a word problem. It says a cone with a radius of 6 centimeters. So let me go ahead and draw myself a picture here. It says it has a radius of 6, and it has a height of 12. Draw in the height. It says a cone with a radius 6 centimeters and a height of 12 centimeters is filled to capacity with liquid. Find the minimum height of a cylinder with a radius of 4 centimeters that will hold the same amount of liquid. So let me go ahead and draw a cylinder. Now remember, the difference between the two volumes is for the cone, we've shaved off like 1/3 of it. So this tells me that the height of my cylinder is going to be shorter than the height of my cone. So it told me that the cylinder radius is 4. So I need to find the height. So the first thing I'm going to do is, because the volumes need to be the same, I'm going to calculate the volume of the cone. So remember, the formula is 1/3 capital BH. So 1/3, my base shape is a circle, so pi r squared, which is 6 squared, so 36 pi, times the height, which is 12. I can simplify 1/3 and 36. So the volume of my cone is 144 pi centimeters cubed. I'm now going to set this volume, so I want to make sure that the volume of the cone equals the volume of the cylinder. So my formula for volume of a cylinder is capital B H. Over here it's the 144 pi. My base area is a circle, so it's going to be pi r squared height. So 144 pi is equal to 16 pi, and I don't know the height. Divide both sides by 16 pi to isolate the h. The pi's cancel, and 144 divided by 16 is 9. So the height the minimum height in order to hold the same amount needs to be 9 centimeters. And that's it for the notes. So go ahead and turn in your completed notes and then work on the homework assignment for 11-7.